Welcome back, everyone. I've got a video for you today about domain and range. I'm going to be working out 3 examples in this video of how you can look at the graph of a given function and figure out what the domain and range is. So the first one I'm going to show you is y equals x. What is the domain and what is the range of these two? Of this function, excuse me. Okay, so I'm going to figure out both of these, and the way I'm going to do that is by graphing this. The graph of y equals x is really straightforward. It's actually just going to be a diagonal line going through the origin. Now, I drew my graph terrible, but what I can do is say, well, when x is 1, what is y? Well, answer to that is also 1. And that's going to be true for all of these points. When x is 3, y is 3, 4, 5, and so on. Same for 0. When x is 0, y is 0. And all of the negative values as well. So right there, I have a pretty good picture of what the graph looks like. And I can just draw it in. There's the graph of y equals x. So what I want you to do now is look at this graph. Thank you, Nickelback. And now that you've looked at the graph, what we're going to do first is figure out what the domain should be. So in another video, I talked about the domain, and I'll just briefly mention it here. The domain is really just all of the x values you're allowed to have for a given graph. So by looking at this right here, how many x values are going to be okay to use for this line? And since these have arrows on it, it means it goes forever. I don't see anywhere where there's any holes in the lines, any places where it just all of a sudden curves down to infinity and then starts back up again. So that means that I'm probably going to be allowed to use any x value I want. And so just by looking, I can say confidently that my domain is all real numbers. A lot of different ways, or at least a few, that you can write that the domain is all real numbers. That's one of them. If you're going to use interval notation, you can write it like this. From negative infinity to positive infinity. It almost looks like a coordinate, but it's not. When you're using the infinities, obviously you can't ever reach infinity, so that's why I'm using the parentheses and not a bracket. So you don't have to write both of these. You just pick one or the other to represent the domain. Okay, for the range, I'm looking at all the possible y values. Now I care nothing about the x values. Range is just saying, okay, well, what am I allowed to use for the y values here? Again, judging by the arrows, I am probably going to be allowed to use any possible y value here. Again, no holes, no places where this blows up to infinity. So my range for this is also going to be all real numbers. And that's how you would look at finding the domain and range, especially for the range. Sometimes that can be really tricky to find. If you have a graph, not so much. So now, let's look at y equals x squared, and let's see what we come up with on that. Okay, for y equals x squared, I'm going to go about this the exact same way, where I just plot a graph. So here we go. Probably have to do x to the third on a different paper. That's fine. So I want to graph y equals x squared. I'm just going to choose points, starting at 0. Why do I pick 0 to start with? Because it's easy. There's nothing to it. When x is 0, guess what? So is y. When x is 1, so is y. This holds true for negative 1 as well. When x is negative 1, then y is 1. So there's the point, negative 1, positive 1. Now, starts to get different when I plug in 2 for x, so 2 for x, y then becomes 4. 1, 2, 3, 4. And this is a graph that's going to be symmetrical, so any value that I find over here, and this is symmetrical about the y-axis because I'm centered at the origin, I can just go ahead and translate another point here. Okay, so when x is 3, that makes y equal to 9. That's going to be way up here. Let's see if I can fit it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Extend this a little bit. And I have a very good picture of the graph of y equals x squared. Hopefully I can trace this in without doing too much damage. That's not bad. Okay, so I have a graph of y equals x squared. And I'm going to try and answer the same two questions. What's the domain? And what's the range? Okay, start with the domain. Since I've got these arrows here, this means that this is going to go on forever. Now, I'm only looking at the x values that this thing can possibly have. So, how many x values are allowed in this? So let's try and ask that another way. If I went out to x equals negative 10,000, is that going to be part of this graph? And the answer to that is yes, eventually. It may not look like it, but with these arrows, this means this goes on forever in the x direction, even off the page, off the camera, off the table, off of the earth, whatever. It goes on forever. And so eventually this thing will hit x equals negative 10,000 and say, over here x equals positive 50,000. Eventually it will happen. So any x value is allowed here, even when it looks like it's not. This is still just x equals negative 2, negative 1, 0, 1, 2, and all the numbers in between that are all being used up. So my answer is just domains, all real numbers. Okay, for the range. Now, I'm only looking at the y values, that's it. So are there any y values, I'll say it that way. Are there any y values I'm not allowed to use? So I can tell by these arrows that this thing is going on forever to infinity. That is true. But when I look down here, just for the y values, this thing stops at y equals 0. Or we could say even starts at y equals 0. Okay, so it looks like the very lowest point of this graph is at y equals 0. At y equals negative 1, is the curve actually touching this point? No, obviously it is not. So that means the range does not extend down there simply because the graph isn't there. The graph's lowest point is here. So that means when I write my domain, I'm going to use this fact right here to do that. The domain is simply all numbers y. They're going to be greater than 0. Now, here's the question. Right here at 0, is this function actually defined? Is this a hole? Or is the graph actually completely going through there in a nice smooth way? And it is going right through there. This is not a hole, it's just part of the graph. So since that's the case, I can make that greater than or equal to 0. So that's the domain and range of y equals x squared. And really, again, you just have to plot these graphs and you'll have them. Okay, for y equals x to the third, I've redrawn this on a different page so I could take up most of the page. Still trying to find the domain and range. And I'm going to go about this the exact same way. Thank you, Nickelback. I'm going to look at the graph. And to do that, I need to actually draw the graph. So the way I can do this, graph got kind of messed up here. I can't draw. Is by just using a table of values. Really, I can do it in my head. You can draw it out. Either way you want to do it, it doesn't matter as long as you get the graph. When x is 0, guess what? So is y. So there's a point on my graph. When x is 1, 1 to the third is 1, so y is 1. If I plug in negative 1 for x and I cube that, well, negative 1 times negative 1 is positive 1. But then times another negative 1, and I get negative 1. So when x is negative 1, that makes y also negative 1. So that's why I get this point down here. Okay, Well, the real change comes when x is 2. When x is 2, then y becomes 8. So I'm going to go over here. Here's 2. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I have kind of an idea for that. And when I plug in -2, I get the exact same result as I got for -1, except it becomes not +8, but -8. So -2, 1, 2, 3, 4, 5, 6, 7, 8. This gives me a pretty good picture of what the graph of y equals x to the third looks like. So I just have to carefully and expertly trace this in, which I, of course, can do. I just mentioned that I wasn't good at drawing, so hopefully this doesn't... Oh boy. Okay, so that's not too bad. That's the graph of y equals x to the third. And looking at this graph, I'm trying to figure out, are there any restrictions on the domain and range? It was pretty obvious when I had this graph for y equals x squared that my range was limited by its lowest point. Domain had no restrictions at all. This thing will go on forever for all the x's. Looking at the y's, I'm going to realize the exact same thing, that even though this thing looks really steep, there are no restrictions on any values for x. There's no holes anywhere on the graph. Nothing that tells me, hey, I can't use that value for x. So that means my domain here is all real numbers. Okay, the range. Is there any place for the y values that I am not going to be allowed to use? In my opinion, the range looks really straightforward in this particular graph because this thing looks like it just wants to take up almost only y values, but it'll eventually take up all the x values as well. It just, you can't tell by looking kind of like this. Okay, so for the range, this thing has no restrictions on it. It has no lowest, no highest point. So that means my range is also going to be all real numbers. So this is a way you can visualize domain and range. You can graph them, and then if you've done the graph correctly, which hopefully you have, you can take a look at your graph and say, well, where are the points that, you know, don't exist or go to infinity? That will mess up my domain or my range. Otherwise, if you don't have that, then it's just all real numbers. Hope this helps. Thanks for watching.